7 miles up, the air outside your window is around 60 degrees below zero, and so thin that without help you would lose consciousness in well under a minute. Yet inside the cabin, you breathe comfortably, the temperature is mild, and the whole volume of air around you is completely replaced every 2 to 3 minutes. So where does all that fresh, breathable air actually come from? The answer is stranger than most people expect. On almost every airliner flying today, the air you breathe starts its life deep inside the jet engines. To understand the system, start with the problem. At cruising altitude, the outside air is freezing, nearly a vacuum, and far too thin to keep a human alive for long. The cabin has to fix 3 things at once. It has to be pressurized so there is enough oxygen. It has to be warmed from deep sub-zero cold to room temperature. And it has to keep flowing constantly so the air never goes stale. Doing all 3 continuously for hours takes a surprising amount of engineering. Here is the clever part. A jet engine is essentially a giant air pump. Before any fuel is burned, the front section of the engine, the compressor, squeezes incoming air to high pressure. Engineers tap a small fraction of that compressed air right off the compressor before it ever reaches the flames. This is called bleed air. It is a brilliant shortcut because the engine has already done the hard work of pressurizing the air for free. There is just one problem. The air coming off the compressor is violent. It can be around 250 degrees Celsius, roughly 500 Fahrenheit at high pressure. You cannot pipe that straight into a cabin full of people. So the bleed air is sent to a set of units under the wing called air conditioning packs. First, it passes through a heat exchanger, a radiator cooled by cold outside air, much like the radiator in a car. Then it enters an air cycle machine, which does something elegant. It lets the compressed air expand and spin a small turbine, and as the air expands and gives up energy, it cools dramatically. In other words, the system uses the air's own pressure to chill itself. By the time it leaves the packs, that once blistering air is cool, clean, and at a comfortable temperature ready to mix and enter the cabin. Most airliners carry 2 or 3 of these packs working in parallel, and the crew can manage them from the flight deck, blending in a little hot air through what is called a trim air valve to set different temperatures in different zones of the cabin. That same bleed air quietly does several other jobs around the aircraft. It is piped to the leading edges of the wings and to the engine inlets, where its heat melts away ice before it can form and disrupt the airflow. It is used to spin an engine up to speed during start. And on the ground, before the main engines are even running, a small jet turbine in the tail called the auxiliary power unit can supply that compressed air, so the cabin stays cool at the gate. A single stream of hot compressed air, in other words, keeps the cabin breathable, the wings clean, and the aircraft self-sufficient. Now the aircraft has to hold the cabin at the right pressure. That is a balancing act. Fresh air is constantly pumped in, but if nothing let it out, the cabin would keep inflating. So at the back of the aircraft sits an outflow valve, a door that automatically opens and closes to let just enough air escape. By carefully metering how much leaves, the system keeps the cabin at a pressure equivalent to about 6,000 to 8,000 feet of altitude, even while the aircraft cruises far higher. The air is always moving through, in at the front, out at the back, never trapped. A common myth is that cabin air is stale and recycled. It is not. On a typical airliner, roughly half the air you breathe is fresh air drawn straight from outside through the engines, and the other half is recirculated. But that recirculated half is not simply blown back at you. It first passes through banks of HEPA filters, the same grade of filter used in hospital operating rooms, which capture around 99.97% of particles, including bacteria and virus-sized particles. Combine the constant fresh supply with that filtration, and the full cabin's air is exchanged every 2 to 3 minutes, far more often than in most offices, classrooms, or homes. The air is also deliberately directed. On most jets, it enters from vents above your head and leaves near the floor, flowing mostly top to bottom rather than racing the length of the cabin, which limits how far anything airborne can travel between rows. For decades, every airliner worked this way, tapping hot air from the engines. Then Boeing built the 787 Dreamliner and did something radical. It threw bleed air out almost entirely. Instead of stealing hot air from the engines, the Dreamliner uses large electric compressors to pull in cold outside air directly and pressurize it. Removing all that hot bleed plumbing made the engines a little more efficient, but the real payoff was for passengers. Without scorching bleed air drying everything out, the Dreamliner can hold cabin humidity around 15 to 20%, instead of the bone-dry 5 to 8% on older jets. That is a big part of why a long flight on a 787 tends to leave you feeling less exhausted. There is also a safety angle. Because bleed air passes near engine oil seals, a rare failure can let a faint smell of oil into the cabin, something the electric system on the Dreamliner sidesteps entirely. It is one of several quiet reasons the industry has been rethinking a system that had gone unquestioned for half a century. So the next time cool air drifts down from the little nozzle above your seat, remember the journey it just took. It was pulled in from 7 miles up, squeezed by a jet engine or an electric compressor, cooled, filtered, pressurized, and delivered to you, and then replaced entirely a few minutes later over and over for the length of your flight.